All right, so this will be a new series where I am going to go through the Freecodecamp curriculum. Specifically, right now, we're going to be going over the Scientific Computing with Python course, walk you through it, see how it goes, give you my thoughts at the end. But we're going to go through this course. It's 300 hours, but I'm sure we can bust through it super fast and cut it down from 300 hours. So we'll see how this goes, but hopefully you guys enjoy this. I just wanted to run this through just in case anyone is kind of curious about Freecodecamp specifically, and then learning Python as well as some scientific computing. We can also go through the data and analysis course as well if people are curious, but let's go through it. I'm planning to do this every Friday. I'm calling it Freecodecamp Fridays, starting a new series. We'll do this every week as long as I'm here, and we'll just keep going through it. So hopefully you guys enjoy and then get some insight on some Freecodecamp curriculum. Again, it's totally free. So we're going to go through the scientific computing first, and then we'll move into data analysis, maybe machine learning later. Who knows? But let's get started. Okay. I did it! Yay! Okay, so introduction to hardware architecture.
Hello and welcome back to Hardware Architecture. Now you might ask, why do I tell you about hardware architecture? Probably you're not going to build any hardware, although it's fun stuff to do, and if you're going to become a computer scientist, which most of you won't want to be, it's a great thing to study, and it's those who build.
I like how honest he is. I love how honest he is. If you guys are studying to be a computer scientist, if you guys want to be, which most of you will not want to be, like dead honest, I love it.
Our hardware are amazingly talented individuals, and it's a really rewarding job. The reason I like talking to you about hardware is because I want to be able to use words at some point and say, oh, secondary storage, or central processing unit, or random access memory, or peripherals, input devices. And I want to be able to say those words, and I want you to be able to understand them. And so I'll start with a little piece of hardware called the Raspberry Pi. And the Raspberry Pi is a cute little single board computer. As we go forward, these things are smaller and smaller and smaller. And the interesting thing is that the architecture of these stays the same, but the number of components drops. So I'm going to start and give you a block diagram of sort of a generic computer and tell you the major parts of it. Now, I'm going to show you some really old hardware, some really new hardware, and then some hardware that is of medium age.
I feel like, is this really necessary?
Program the CPU. And if you
I've done this before.
Had bought a desktop computer, platters that are all spinning around.
Okay, I feel like most people should know that, but I'm not going to assume that, obviously. We'll just keep moving through because that I feel like this video was not. Here we go. Are we actually learning?
Hello and welcome back.
Interesting choice of attire.
To Python as a language, you'll notice that I'm wearing a hat. And part of the story of the hat is that where I work here at the University of Michigan School of Information, my office is in this building called North Quad. And we call it Quadwarts sometimes because it's sort of got a square. It sort of imitates an Oxford quad. And so it seemed to me to evoke notions of Harry Potter. And when we first moved into the building, I joked in one of my classes that we should have a sorting ceremony for all the students as they come into North Quad for the first time. And so that was cool, and I thought that I would belong in Gryffindor, like everyone wants to be in Gryffindor, right? They're the good guys. And my students told me that I couldn't be in Gryffindor, that I had to be in Slytherin. So you'll see me drinking tea throughout the course out of this teacup. It's my Slytherin teacup. I picked that up from Harry Potter World. I went down to Florida and visited.
What are the odds that he only went down to actually get that cup? Like that was his sole purpose, was just to get that cup. I like this guy. Whoever has him as a professor at the University of Michigan, you guys are lucky. All of you are lucky.
Visited Harry Potter World, and the reason that I was sorted by my students into Slytherin is also because I teach Python, and Python is like a snake. And so if you think about the people from Slytherin, they are capable of talking to snakes. And the class that we were doing the sorting was a Python class, and so it sort of made perfect sense that you would have to be in Slytherin if you were the Python teacher. And of course, your name is Charles Severance, and then that sounds kind of like Severus Snape. And so I just accepted that.
Yeah, this guy's really cool. He's really, really cool. But so from now on, we refer to Python as Parseltongue, right? I think that's valid enough. Most of us have seen Harry Potter, right?
I'm in Slytherin, okay? So you all can be in Gryffindor, but I can't.
I'm more of a Hufflepuff
So I'm the bad guy or the good guy, depends on how you look at it, right? And so what I'm going to do now is I'm going to, bring you into Slytherin as well. because I'm going to teach you the Python language. Python is the language that we Pythonistas talk. It was invented about over 20 years ago by a
Pythonistas. Okay, if I was gonna name a subset of my subscribers, this guy's got the jokes, bro. This guy's got it.
fellow named Guido van Rossum, and away we go. Now, even though I'm using this whole snake Slytherin thing, it turns out that Python was not at all named for Harry Potter, because Python was invented, almost 2 decades before Harry Potter was created, and it wasn't for the snake. It was actually Monty Python's Flying Circus was the inspiration for Python.
Oh, I didn't know
the
that.
name Python, and because Guido van Rossum really wanted to create a programming language that, while it was powerful underneath it in its very nature, was a very powerful language, he wanted it to be a language that was fun, and he wanted it to be a language that was approachable. And so that's why Python recently has become so absolutely popular, and it's easy to learn. And it's
So Monty Python was actually the inspiration behind Python.
but it's also powerful, and that's sort of the magic of Python, is the ease of learning it, the brevity of the programs, the shortness of the programs, and the power. And so we are going to become Pythonistas. Now, as you
I don't know why that gets me so many every single time. Pythonistas. I'm down with it. I'm so down with it.
learn to be a software developer using the Python programming language, you are going to encounter syntax errors. And I remember when I used to get syntax errors, and I remember my first programming class, and I would type on cards.
Microsoft used to do this, right? Like all of Microsoft's code, I mean, everyone's code used to be on a card, but I remember watching the documentary with Microsoft and or some sort of video where with Bill Gates and all that stuff, and their code was heavily on these cards. It's kind of crazy.
And I would upload those cards to the computer, and the computer would say, "You're not worthy." And I'm like, wait a sec, those are pretty good cards. How could you be so critical of me? I'd say syntax error. And I really got sort of a really bad attitude that somehow this computer didn't like me, and that I would make cards, it would complain, and I would make changes to the cards, and it would still complain, and I'd make changes, and it would still complain. I'm like, how can I win in this situation? And
I feel, should we skip part of this? I like this guy, but I just want to get to the curriculum,
Seven, there's some little thing. Python at a command prompt. Please, please, please help me, And so it's so much code. So we have a number of different ways to sort of encode our instructions when we talk to Python. One is we just run Python interactively on our computer. Hopefully by now you've got it installed, and you just type Python at a command prompt. So either a Windows command prompt or a Linux command prompt or a Macintosh command prompt. And I got some examples of how to sort of get this all.
Okay, we can just probably skip this part because he's kind of explaining some very simple stuff, but what we'll print out after running these 2 lines of code. So we assign x, the variable is equal to 6, and then we print x, so it'll print 6. For those of us who know programming languages, I'm sure we know this already. The value here is the int 6, so it'll print out 6. Watch me be wrong. Watch me had been completely wrong. That would have been hilarious. Okay, elements of Python. Let's put this through 2x.
So now we're going to start learning the actual Python language. So what do we say? You can think of this as almost like writing a story. We're going to start with the basic vocabulary. We're going to talk a little bit about lines or sentences, and then we're going to start talking about how to put those sentences together to make a coherent paragraph. And you just have to accept the fact that when I start teaching you this stuff, it's not going to make sense for about 6 or 7 more chapters. And so just sort of bear with me. I remember when I first learned, it went from me confused. Holy mackerel, this is awesome. And so I expect many of you will go through that same thing. So just learn the first parts, accept the fact that it doesn't necessarily make sense in a big picture, and just bear with us, okay? So we'll start with vocabulary, we'll start to make sentences, and then we'll have little short stories and paragraphs, okay? And so this is a short story about how to count the words in Python. It's got a couple of paragraphs, and we are going to look at all of this stuff eventually. So we start with a set of reserved words. And what are reserved words? Well, they're words that Python expects when you use these words that they're going to mean exactly what Python expects to mean. And what it really means is you're not allowed to use them for any other purpose than the purpose that Python wants. It's sort of part of the contract. It's like when you have a dog and you go, "What did you think of that television program?" And the dog has no idea what you're saying. And then you say, "Do you want to wait until Saturday to go to the veterinarian?" And the dog still doesn't know what you say. And then you go like, "How would you like to take a walk?" And then the dog goes, "Walk." I know what that means. And then hits the door, right? And so the way the dog sees you is blah, 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 walk, blah, 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 blah.
This is funny with
Blah, 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 walk. That's kind of how Python looks at these reserved words. When you say class, go class. Oh, I know what that means. Now, if I say zap, it's like, oh, zap something that you get to decide, or it's maybe a variable name. So reserved words are simply words that when you use these words in Python, and there's only a few of them, like and or del, or if maybe, pass maybe, in. A lot of these, you won't end up using them, as these are reserved for Python and part of the Python vocabulary. This is Python vocabulary. Now, when we move from words to sentences, you see that Python is a series of lines. A Python program is a series of statements. They have an order because the computer wants to know what next, next? So what next is start at the beginning. So I already talked about an assignment statement that basically says x equals 2. This is not a mathematical statement. This is a directive to say, take this variable 2, this value 2, this constant 2, and stick it in a location in your memory. And remember that I asked you to name it x. X is a variable, something you made up. You chose that. And so but it's Python's job to remember it. So this says go to whatever that x is. There's a 2 in there. Now pull that x back out, add 2 to it, which makes it 4, and stick it back in x. And so that makes this a 4. So x is a 4. And print x says, go look up that thing that was an x and print it out. And so these are like, each line has something to it. I'm using a reserved word. Well, actually that's a function, but it's a reserved word too. And so there's reserved words and all these things. And combine these, there are operators. A plus is an operator, equals is an operator. These things do things. And we'll learn all this stuff in time. So the basic building blocks of lines of Python. Now, as we take these lines of Python and build them up, we end up making paragraphs, programming in paragraphs. And so one of the things that it's important is I showed you how to do interactive.
Okay, so doesn't this kind of like throws a red flag to me? Doesn't this not overwrite the initial value we assigned it in 43 here? Am I wrong in saying?
So you just type a statement and statement and statement. Those get really tiring after about 3 or 4 lines of Python because you start making mistakes and you have to start over. So the better thing to do is to, as your program gets a little larger, to write a script, put your Python instructions in a file, and then tell Python to read from the file and then run the script as it's entered in that file. We tend to name these files with .py, and I've got a series of videos that you can watch to figure out how this all works. Like I said, you can type interactively to Python, and it's a great way to experiment with Python, check to see if a statement does what you think it does, but script is the way, after we are past 1 or 2 lines of code, we write it in files and then run it separately. So there are a couple of basic patterns, and it's really important to understand each of these patterns, and like I said, we'll teach you these patterns separately, and then we'll combine them together. And when you combine them together, is when you say, oh, that's what a program is. So you have to suspend disbelief. We have a couple of different patterns. One is a sequence of steps. Do this, then do this, then do this. Conditional is like skipping something. Repeated does it over and over and over again. Computers are really good at repeating stuff, much better than people. People get tired going over and over doing the same thing. And then we have store and repeated steps as well. And so if we take a look at this, and we take a look at a Python program, this is a piece of code, this is a little script. If you type this into the code, take this code, Python code into a file and ran it, it starts at the beginning, and then it goes to the next line, and the next line, and the next line. And Python executes the scripts as you write them. So it says stick a variable to find a place called in your memory called x, stick 2 into that, okay, then go to the next one, print that out. So the program's producing output. Now go read and print that. This side over here is called a flowchart. I'm not going to make you draw flowcharts. I'm only going to draw them a few times in ways that I think will help you. But you can think of it as Python, when it finishes something, it goes on to the next one, unless you tell it otherwise. Finishes this, goes on to the next one. Finishes this, goes on to the next one. Finishes this, the program is all done. And so that's sequential steps. You just type them in. They're important, but sort of interesting because you can't only get so far, and you can't make them intelligent because it's always going to do the next one. So the next thing we do is what are called conditional steps. And this is where it starts getting intelligent. I mean, where you are able to encode your brain into the computer. Oh, wait a sec, let's only do this step if something is true. And the syntax that we tend to use here is the reserved word if, okay? And so if is like a little fork in the road. You can go one way or you can go another way, and you're asking a question. So inside the if statement right here, there is a question saying, is x less than 10? That resolves to a true or false. If it's less than 10, that's true. If it's greater than 10, it's false. And so then what we do is, if it's less than 10, we have this indented block of code. There's also this colon that tells us we're in the beginning of an indented block of code. And so what it basically says is, if this is true, run that code. If it's false, skip that code. So it can either run it or skip it, depending on this question that's being asked. Now, if you look at this code, it's pretty obvious what's going on. It comes down, x is 5. If x is less than 10, that's true. So it runs this code and prints out smaller. And then it comes back here, de-indents, the next basic sequential. This ends up being kind of a block. If x is greater than 20, if x is greater than 20, oh, come back. If x is greater than 20, this turns out to be false because x is 5, and so it skips this. So the bigger never comes out, and then it continues on and prints fini. Oops, that's a typographical error. Make that a lowercase print, and then prints fini. So it comes in, runs this, skips this, and then finishes. Statement sequentially with this while. While is a keyword, and it's asking another question. That's a true/false question. Is n greater than 0? I read this as long as n remains greater than 0, keep doing this indented block. And you have a colon at the end, and then you have 2 lines of code that's indented. So that tells us what the loop is, and then this is now de-indented. And so it comes.
I like these diagrams that he's making. It makes it like really easy to know like the sequence of things, especially in like while loops or if statements. Like these are all really good to know, especially if you're new to programming. Knowing the sequence of having like 2 if statements, I feel not most people, but some people could think that like if this first conditional was true, right, this one would be skipped ultimately because this is already done. But like these are 2 separate ones, and it'll run this either way unless you break or return here, right? So it's these diagrams are really, really nice.
So here is the last one we'll talk about.
Right, with this while. So like if n is greater than 0, if it's no, it instantly goes down into the print blast off. And it does not run what's inside of the while loop block. It helps 100%. Because then you actually visually get to see the sequence and order of everything, especially in conditionals where it's kind of like, I relate it to orchestration in data engineering where like certain things will trigger something, right? So if this is a no, it's going to trigger this job and run print. And if this is a yes, it's going to run everything inside of the block, which is print the number n, and then n equals 5 minus 1. So that's really good.
This is another program, and the key is that we're going to use the same choice where we're going to go in, but then we're going to run for a while, and then we'll have an exit condition where we get out. So this is a repeated over and over and over and over again, and this is the essence of how we make computers do things that are seemingly difficult. Well, they're more difficult for people, okay? And so how do we encode this notion that we want to do something for not forever, but for a while? How do we encode that notion? And so we do it in this way. So we have our statement sequentially with this while. While is a keyword, and it's asking another question. It's a true/false question. Is n greater than 0? I read this as long as n remains greater than 0, keep doing this indented block. And you have a colon at the end, and then you have 2 lines of code that's indented. So that tells us what the loop is, and then this is now de-indented. And so it comes in, and if this is true, it runs these 2 lines, 5, and then it says n equals n minus 1, which makes n be 4. It goes back up, and it goes up and it asks this question again. Is n greater than 0? If it is, continue on and prints 4, and then subtracts it, and it does that 4, 3, 2, 1. Then it comes up, and now after this, n is now 0, and n is no longer greater than 0, so it takes takes sort of the exit ramp and goes down here. So it takes the exit ramp of repeated, sequential,
Okay, let's see.
together. So this is a bit of sequential code. Comes in here, runs this, which happens to ask for a file name, then it opens the file, it creates a data structure called a dictionary. This is all sequential. Now the for is another form of loops. So this is going to loop for a while, and then this is within a loop. We can even have 2 indents, and that's another loop. So these are like repeated, and then it goes down to the next sequential bit. Then it does this. Here's another loop. It's going to run, and then here's a conditional. It's going to run, and then when it's all done, we print out the last thing. And this is, of course, is the program that does the most common word and prints that most common word out. And so this is a Python short story. It reads some data. It reads the name of a file. It opens that file. It talks to trust that you are learning important things, and that it all makes sense.
Okay, so I'm guessing we're all good on that. We don't have any questions. X equals 43. X then equals x plus 1. Print x. So you guys said 44. That looks like it's the only thing that makes sense. I would have said x plus 1 because you're assigning x to equal 43, but then you're reassigning here. So I don't know. What do you guys think? X plus 1 or is it going to be 44? Okay, 44. You would think though. You would think. You see how confusing that could be though, right? Like it looks like a reassignment. It definitely looks like a reassignment. Like that's doing x equals 43 and then another x equals x plus 1 can look very, very confusing. So in a sense, I'm really glad that they did that as an example to throw people off.
Hello, and welcome to Chapter 2. Now we're going to continue to talk about the building blocks of Python, variables, constants, statements, expressions, etc. The first thing we have to talk about is constants. These are just things we call constants because they don't change. They're numbers, strings, etc. And we use them to sort of start calculations, or if something is greater than 40 hours, we're going to do something. So 40 is the constant in that situation. So we have 123, we have 98.6, we have hello world, which is a string by enclosing in quotes. We pass each of these things to the print function, and a side effect of the print function is that we see the output. So print 123, prints out 123, print 98.6, prints it out. So these are just really the syntax of constants, and without constants, we can't write really much of anything. The other sort of foundational notion of any programming language are the reserved words. And like I said before, reserved words are these special words where Python is listening for them, and there is very special meaning. So when Python sees if, it's not just any other word, it means how it implements conditional execution. Variables are the third building block, and that is a way that you can ask Python to allocate a piece of memory and then give it a name. And you can put stuff in that. Well, sometimes you just put one value, later we'll see.
Okay, so this is like you said, we're just assigning a variable and we're storing that value in memory.
Collections in chapters 8 and 9, we will see the more than one value can be put into a variable. And the variable, how we control the variable is through the assignment statement. And as I said before, it's important to think of the assignment statement as having an arrow to it. So this is not saying x for all time is the same as 12.2. What it's saying is take 12.2, find a place, find some memory in your computer there, Mr. Python, give it a label x, we get to choose the x. That's the variable part. We chose it. Right? And then stick 12 in, and then same is true for 14. We'll find another spot, name it y, and then put a 14 in there. So think of this as an arrow every time you see that equality, the assignment. Now, these variables hold one value. So now if we have these 3 statements, these 2, and then the third one executes, it says put 100 into x, but that wipes out the old value of 12.2, and it rewrites it with 100. And so we can change the variables. That's another reason that we call them variable. There are some names, now there are some rules for making variable names.
Right. In this case here, we're now overwriting what was stored in memory initially as 12.2, and then we come back down, and that's a reassignment here. This right here, where you're now reassigning x to be 100 in memory. So that itself would then, if we got asked the same question, it would then be 100.
And so we can change the variables. That's another reason not to, as normal programmers use underscore, we tend to reserve those for variables that we use to communicate.
Must start with a letter or underscore. Must consist of letters, numbers, and underscores. Case sensitive. Yeah, so here's the difference, I guess, for me, or really anyone else that's coming in from another programming language such as JavaScript. JavaScript has camel case. That's not the case at all for Python. It has underscores, starts with underscores, or
Python itself. So when we're making up a variable, we tend not to use underscores first character. You can have letters and numbers and underscores after the first character, and they're case sensitive, but it's really a bad idea to use case as the only differentiator. So in this case, spam egg, spam 23, and underscore speed are all totally legit. We would probably not use this one unless we were actually doing it because Python told us to use that variable. 23 spam starts with a number, line starts and dot is not a legitimate variable character. And spam, capital spam, and all caps spam are different, but this is not something that you want to sort of depend on too much. So that's just the rule names. We tend to start them with a letter and then use letters, numbers, and underscores. Underscores other than the first character are generally pretty common, and you'll see those used a lot. Now, when we're choosing one of the things about variables is we get to choose the name. We get to choose the name x, choose the name y. And so sometimes we like them short, but sometimes we want them descriptive. And the notion that of making variables descriptive is often confusing to beginning students. Sometimes it's really helpful to, if you're going to have a line of text and you name the variable line, that's great because the next person reading your program says, oh, that must be the line of text. Whereas it also can become misleading that the name of a variable somehow has meaning. So sometimes we're writing singular variables in plural, like friend and friends. And the answer is no. So sometimes we pick variables that make no sense. Sometimes we pick variables that make a lot of sense. This is just something that you as a beginning programmer are going to have to understand, that we can pick anything we want. And so you'll see, I'll try to call attention to this in the first few lectures as we go through. So here's a bit of code with an assignment statement, 2 assignment statements, a multiplication, and a print statement. And you can say, what is this doing? Now, Python is perfectly happy with this code because it assigns it in there. You have said, please go give me this as a label. And then we assign 2 variables. And then we're carefully pulling these 2 variables back out, multiplying them together and sticking them into yet another variable, and then printing that variable out. That seems like, we can figure out what it is. You just have to look really carefully. And a single character mistake, and Python is going to be, pretty unhappy. Okay. So that's one way to write this program. It's hard though, because you can
imagine having to deal with, this would be chaos. Absolute chaos. The only difference here is a 9A FD and the 9O CD, but it's you have to really look so close to even see that
stuff. It's not very friendly to anyone who might read your program. Now this looks a little friendlier. It's the same program because Python just wants a correspondence. You pick A, you pick B, and you pick C, and it's really much easier for us to see what's going on. Yes. And so this is, in a way, going from here to here is much friendlier, but we can be even friendlier if we pick mnemonic variable names. So this is not mnemonic. This is short and convenient. This is long and inconvenient. Python is happy with any of these. Here, on the other hand, is another version of the exact same program. And now you think to yourself, oh yeah, now I get it. 35 is the number of hours. $12.50 is the rate. And then we're going to multiply the hours and the rate and come up with the pay, and we're putting out the pay. Now, whoever wrote this program is helping us greatly understand what's going on. And that's good. Choosing variable names. Python, again, all three of these are the same to Python. Choosing variable names in a way that help your reader understand what's going on is a great thing. The problem is, the danger is, if you read this and you think that somehow Python understands payroll, that if you name a variable hours, that Python knows what hours means. The answer is Python really doesn't care what you name the variable, as long as what you name it, you use it, right? And so you got to be careful. And so you'll see sort of deserves, I guess that's probably the best way to say that. So we talked about constants, we talked about reserved words, we talked about variables. And so here we have a sentence, like we've already done some of these things where we set x equals 2, we retrieve the old value of x and add 2 to it, so that becomes 4, and then we print 4 out. Print is a function that's built in, and we pass in whatever we want to print out. So this parentheses is part of a function
So as long as a variable contains an assignment with an expression, or that expression slash what you mentioned earlier, which is an operator, this doesn't reassign what x was stored in. So this then pulls 2, and then we effectively get 2. If this did not have the operator and or expression, then we would just be ultimately reassigning that variable.
Okay, so an assignment statement, you have to really get your head around the notion that it has this arrow nature, and that it evaluates this entire right-hand side before we change the left-hand side. And so you can think of this sort of as at time step 1, it does this, and then at time step 2, it does the copy. And that's how you can have something like x on both sides of an assignment statement. And so if, for example, we have x, and x has 0.6 in it, x has 0.6 in it, what happens is that it sort of ignores this part right here and evaluates the expression. So it pulls the 0.6. Everywhere x appears, it pulls 0.6 out. Then it starts running these calculations. And that's how you can have something like x on both sides of an assignment statement. And so if, for example, we have x and x has 0.6 in it, what happens is that it sort of ignores this part right here and evaluates the expression. So it pulls the 0.6. Everywhere x appears, it pulls 0.6 out. Then it starts running these calculations, and then it has the new value. After all the calculations are done, then and only then is it going to put that back into x. And so it sort of takes that and puts it back into x, and then wipes out the old value. At this point, this has all been taken care of, and it's been reduced down to this 0.93, and so that is what's put in as the new value.
Okay, so that makes more sense. This is what we talked about before, where if there is an operation going on and it's using the same variable name, right? So before x was assigned 0.6, all of this goes through its actual process of doing the expression using the old value that was stored in memory. And like he said before, once all of this is done running, the new value will then be reassigned. So we're not overwriting immediately. We're overwriting after the expression is run. So the same example before, so where this one was x 12.2 and this was x equals 100, we're immediately overwriting because there's no expression. Once we add the expression here, 12.2 would have been used, and then we rewrite x. So that makes sense. Anyways, moving on, what is the symbol used in an assignment statement? Always equals. And we're going to intermediate expressions. We're moving fast.
So we're now going to talk about expressions. Expressions are a little more complex calculations that we can sort of do on the right-hand side assignment statement. So one of the things about expressions is operators. And the operators in computer programming are often very much the same as the mathematical operators, but we don't have all the fancy characters that we have in mathematics. And so we have to choose what's on the keyboard. And then we really go back to the 1960s and 1970s, and we use what was on the keyboard in the 1960s and the 1970s to make these operators. So plus is addition, minus is subtraction. We don't have a times sign or a dot in the middle, so we use the asterisk as multiplication. Division, we can't put two things over top of each other, so we use slash for division. Raising to the power, because it didn't have little characters back then, is star star, which is raising to the power. And then remainder. Remainder is when you do integer division, it's also called the modulo operator, the remainder, not the quotient. I've got a picture of that coming up.
I'm gonna be honest. I always forget these. Obviously not the simple ones, but like the multiplication throws me off sometimes. The division one throws me off because in division, we'd always use modulo instead. Like when you were actually writing it out, not in programming. So like I always forget that remainder is this one, power is this one, division is, and multiplication is the asterisk. I always forget, and I always have to look it up. But I think that's the point, is that it's fine.
So here's a whole series of little examples of this, right? So we've already seen, the plus, x equals x plus 1. Keep remembering that these assignments are arrows, basically. Arrow, they have a direction. Multiplication, 440 times 12. Dividing this by, that's division, over 1,000, 5.28. Here we're going to put 23 into JJ, and then we're going to do modulo. So that says, take 23, divide it by 5, and get me back the remainder and put it in KK. So this is the expression that evaluates like this. Take 23, divide 5 into 23, 4, remainder 3.
Right, yeah, sometimes I use the x instead of multiplication, but obviously that doesn't work. And then like you said, the dot. I don't know if you guys use the dot. Like it would be like 4 dot in the middle 3, and that would be 4 times 3 for us. So it was just very confusing.
The 3 is what comes back up here. Okay, and so that is the remainder. It's also called modulo operator. It turns out that for things like picking a random number and then picking the modulo of 52 is a way to pick a card randomly. So this modulo operator is actually, especially in games and other things, super useful. So that's the various operator. It's important to know which of these operators goes first. It's called operator precedence. Now normally we put parentheses in, like so if I put the parentheses in here, I'd say this goes first, parenthesis, then this goes first. Oh, actually not that one. Oops, got that one wrong. This happens first, this happens, then this happens. Okay, and so but it's important for us to be able to know if there were no parentheses, the order in which these things will happen. So the way things work in terms of op precedence is parentheses are the most important thing, followed by raising to the power, all else being equal. Multiplication and division are all equal, and then addition, and then within it's adding left to right. So let's see an example of how this works. And so if we take 1 plus 2 to the raised to the 3 power divided by 4 times 5, and we print out what comes out of this. So the way I did this when I was taking exams back many, many years ago when I was first in computer science is I write it all down and I look for the highest precedence thing. Now parentheses would make this easy, but exponentiation is the first one, and that's going to be 8. 2 to the 3rd power, 2 times 2 times 2 cubed is 8. Then what I would do is I rewrite the whole thing with the 8 there, and now I look across and I'm looking for multiplications because the power's been done, and that's what I'm looking for next. And then there is both multiplication, division. They're equal. They're at the same level. And so what happens is they're done left to right. 8 divided by 4 happens before 4 times 5. And so the fact that it's not 4 times 5, but instead 8 times 4 is because of the left to right rule. So then this gets rewritten to be 2, 1 plus 2 times 5. And this one, multiplication, is the top one. So that does this next. 2 times 5 becomes 10. I rewrite it again. And then 1 plus 10, addition, is the lowest thing. And that's how we end up with 11. And so that's how I would do these problems if I ever saw the problem on an exam. And it's a fun problem to put on exams because there is one and only one answer. And every programming class has usually at least one slide about this stuff. So like I said, the rules go top to bottom, parentheses, power, multiplication, addition, and then left to right within it. So we talked about variables and computing values to put inside variables. But the one thing you kind of also maybe noticed it as we go by is we have different kinds of data. We call it type. Is this a type integer? Is this a type floating point number? Is it a type string? What is going on here? And Python is pretty smart about various kinds of types of data. And so, we're adding 1 plus 4 here, and Python knows as it looks at this that that's an integer and that's an integer, and we'll add it together and make it an integer. So that thing is an integer. We can also use this plus to concatenate 2 strings. This is hello blank plus there, and plus looks here says, oh, that's a string and that's a string. So I know what to do with strings. I will concatenate those 2 things together so it becomes another string that gets assigned into EEE, and it's hello space there. Plus doesn't add the space. I added the space by putting it right there. And so these operators are kind of smart in that they kind of know what they're dealing with, and sometimes they will do one thing or another depending on the kinds of values, variables, or constants that they're working with. And so sometimes type can get us. So here we have EEE, which is hello there because we concatenated these 2 strings together, and now we're adding 1. And the problem now is that it looks on one side and says that's a string and that's a number and says I don't know how to do that. This is another one of those annoying errors that you think that somehow Python doesn't like you, but it just is confused. If you look at these things, traceback always means I quit. It means I stopped, I ran, I'm quitting now because I don't want to go any farther because I become confused. So your program stops running and you say, here's why I stopped running. Because we're typing interactively, it's always line 1 here. Type it, but if you read carefully and you don't get too stuck on too much stuff, line 1 that tells us something in module type error can't convert int object to stir implicitly. So that's an integer right there, and that's a string, and that's what it's complaining about, that little bit right there. If Python is so grumpy about types, then we should be able to ask it about types. So it turns out that there is inside Python a built-in function called type. So we can pass into type. So the syntax is calling a built-in function named type. Parenthesis is the parameter we're saying.
I think another thing to note is that Python is not dynamic, or is dynamically typed. It's not explicitly typed. So you're not actually this is just inferring its type. Obviously that EEE initially when it's stored is as a string. So this isn't like any other strictly typed programming language where you have to strictly say that EEE is going to be string. It's just inferred.
Hey, hello, tell me something about the type of the variable EEE. And so this is a function, the parentheses are part of the function call, and it says, oh, that would be of class string. And then we can pass in a constant and says, hey, what about hello? The string hello, it's like, oh, that's a string too. What about a 1? Well, that's an integer. And so we are asking through the type function what the type of either a variable or a constant is. And there are even several types of numbers, and we'll even see booleans and others later. Like 1 with no decimal, that's an integer number. 98.6 with a decimal, that's a floating point number. And so, constants can be both integer and floating point. And I'm just asking over and over and over again, what is the type of what's in XXX, what's the type of what's in temp, and what's the type of the constant 1. And what's the you can also use a set of built-in functions like float and int to convert from one to another. And so this basically says, I want to convert, let's go back. I want to convert 99 to a floating point number. So this is a function and it's participating in this plus, but before I can finish the plus, it turns this into a 99.0. The difference between 99 is an integer and 99.0 is that it's a floating point number. And that actually turns this computation, as it looks to the left and looks to the right, oh, I've got a floating point number on one side, integer on the other side, and so I'm going to make my calculation overall be a floating point calculation. I can also pass into the float function. I can say, take this variable I, which has a 42, also an integer, and then give me back a floating point. So that'll be 42.0, pass that into f, we print it out, and it is indeed 42.0, and it's a float. And so it knows the type and value in any variable. This is an integer, a value 42. This is a float, a value 42.0. Integer division in 2 was kind of weird, and it was one of the big things that they changed between. Now I'm going to have it. We can convert this. We can call the int function, which is like the float function, and pass a string in. So it says, hey, take this and turn it into
string conversion. This one might be useful.
A floating result in. We've been talking about converting from integer to floating point, but you can also convert from string to integer or string to floating point. And so here we start out with a little string value. Now it only works for strings that are made of digits. So quote 1, 2, 3 quote is not an integer. It is a 3-character string that has 1, 2, 3 as the characters in that string, which is very different than 123. We say, what is the type of this? It's a string. We say, let's add 1 to it. And it says can't convert int to string, so that blows up, right? Because this is a string, both sides, string plus an integer, not good, okay? But we can convert this. We can call the int function, which is like the float function, and pass a string in. So it says, hey, take this and turn it into an integer. So take the input of sval, which is the string 1, 2, 3, and give me back an integer representation of that, which is going to be 123. So we say, what kind of thing do we get back? Well, we got back an integer. We can now get 124. And so you have to manage the type of things, and you can convert from one type to another. Now, int is not magic. If you send something into it, a string that doesn't consist of digits, then you're going to end up with another error. Invalid literal for integer with base 10, blah, 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 blah. So it's really complaining. It says, I want these to be numbers here, and you just gave me letters. So that's going to cause this to fail. Another thing we're going to do with variables is, just like a print function takes something, a list of things, in this case, a string variable, and then prints some output in the program, the opposite of that is input. Actually, input generally happens before this way, or you can hear automatically. We talked about in. We talked about out. Now it's time to write our first meaningful program. And so this program has to do with those who have traveled internationally. If you travel to the United States and you travel outside the United States, you notice that there is an elevator convention that is different inside the United States. In the United States, in the ground floor, in the elevator, that's 1. If you walk on the ground floor in Europe or many other places in the world, then the elevator is 0. So we have written a small app that we're going to put up with called Elevator Floor Conversion App. And it's going to ask us, we're in Europe and we're lost, and you say, well, what floor would this be if I was in the United States of America? And so we have to read the floor that we are at in Europe, and then we're going to convert it to a US floor and print it out. This is very silly. silly, but it is a pure essential program that as program starts, we do the input, and on this right-hand side, we convert that string variable to an integer, so that becomes the integer 0. We add 1 to it, and then that becomes 1, and then we assign that into USF. I've named this variable United States floor, right? So imp is the input, and USF, that's mnemonic. It doesn't know anything about elevators. It's just I picked a variable is. And you could see that I could write this on 4, and it would say 3. I could write this and say 7, and it would say 6. This is an amazing program. It converts floors in a European numbering scheme. Wait, actually, no, I got that wrong. Hang on, let me clear this. I wasn't thinking clearly. I could type in 4, and it would give me back 5. I could type in 6, and it would give me back 7. See, I'm confused. Haven't been in Europe in a couple of months, and so I forgot all about the floors. But that's the idea. Now, this is a super simple program, not super useful, but you get the idea that we're going to pull some data in. We're going to do some intelligent thing. Soon this will be hundreds of lines of code. So then we going to present the results to our user.
What we'll print out after running this code, okay, we're just going to keep going. So 15 height equals 12 print height divided by 3. What was that, 4? Wait, it's a float though. I'm assuming this is going to turn into a float. Chat, am I wrong? Because height is of type float. Yeah. Okay, so that's one thing to take into account when you're doing that. It's just the type, that section of typing is really, I feel like that's one of the more common errors that people are going to run into is typing, right? Obviously, it's different when it's a string to an integer. You obviously can't do that. So there's just different things. So we're back to conditionals. Right.
Hello, and welcome to Chapter 3, Conditional Execution. In conditional execution, we meet the if statement. The if statement is where Python can go one way or another way, and it's the beginning of sort of our way of making Python make decisions for us. So we just that we can use.
Okay, so these are comparison ones. These are pretty standard. I always had a hard time reading this when I was growing up. Still sometimes takes me a second, but I can always say like less than and equals to, greater than or equals to, greater than and not equals to. The thing that's different here is that there is no triple equals as opposed to JavaScript, where triple equals, I think, strictly checks for types and stuff like that. So there is that. Because I think in JavaScript, you can say like string of 5 equals 5 and it would still work. Something like that. I don't know. Which code is indeed correctly to print yes if x equals 0 and y equals 10?
Say, is this true? So again, we're kind of limited to the key on computer keyboards in 1940s and 1950s. Less than or equal to. So we didn't have fancy math characters. So we just concatenated less than equal to be, less than or equal to double equals. Is asking, is this equal to? And so that's a little tricky. The equal sign is that assignment operator. If I was building a language today from scratch, I would probably make assignment the arrow and the equals question to have an equals. Or I might say somewhere I would say question equals. But I'm not building this language, so that's not up to me. So this is the question. Double equals is asking the question is equal to. Greater than or equal, greater than, and not equal. So this is the exclamation point is sort of like not equal. So that's sort of not equal. So that's how we do not equal. So we take a look at some of these in some examples. All of these are going to be true because of the way x is set. If x is equal to 5, that's the question version. That's true or false. It'll execute that. If x is greater than 4, it's going to execute that. If x is greater than or equal to 5, it's going to execute that. Here's kind of a shorthand where if there's only one line in this block, you can kind of pull it up right on the same line after the equals. If x is less than 6, which it is, true, execute that. And if x is less than or equal to 5, do that. And if x is not equal to 6, do that. Now, like I said, all these questions have been carefully constructed so that they're true, just to kind of show you the syntax of those comparison operators. Now, you don't just have to have a single line of text in the indented block, and this will be something you're going to get used to. So if we indent more than one line, then the conditional code is actually these 3 lines.
But the diagrams are so good.
If statement, you come in, you do an indent, and as long as you stay indented, you stay in that if block. If it's false, it just skips all of those. So the way this is going to execute, x is 5, print before 5 is x equal 5, that's the question mark, and that's true. So it's going to run all these, and then come back, and then continue on, and then de-indent, so all this, right? And then it says x equals 6, well that was false, so that skips all of them. So none of these lines of code run, so these actually don't run, and it says afterwards 6. That's a mistake. Those don't run right there, okay? Because x is not equal 6, okay? So indentation is an essential part of Python. Now, we use indentation in lots of programming languages, off blocks, to show where blocks start and stop, but in Python it's syntactically correct. It is, you can make an error if your indentation is wrong. After an if, you must indent, and you maintain the indent as long as you want to be in that same if block, and then when you're done with the if block, you reduce the indent. In this rule of indenting, comment lines and blank lines are completely ignored. So we're going to tend to like put 4 spaces. 4 spaces ends up being the normal thing that we do, and you see all the right has 4 spaces for each indent. If I go in twice, I use 8 spaces, and we have this instinct of wanting to hit the tab key to move in 4 spaces. Now the problem is that 4 spaces might line up the same place depending on how tabs are set, but Python can get confused by that, so we tend to avoid using actual tabs in files.
Yeah, so like in JavaScript, usually these things are wrapped in like curly braces or parentheses to know that whatever is inside that belongs to that block. But the indentation here in Python is what is important. So this is not valid at all. Like there's no indentation, there's no block in this if, or this, right? So this is not valid at all. Now these two belong inside of the initial if statement here. So this is one whole block. So I think the thing we have to figure out is if x is equal to 0 and y is equal to 10, what's going to actually print yes and indented correctly? So yeah, chat, what do you think? I'm leaning towards the last one.
And so most programming text editors, like if you're using Notepad or Text Wrangler, there's a place to set the tabs, to say don't put tabs in this document, but every time you hit tab, move over 4 spaces. Tab, but it's like space. Now the nice thing about Atom, and this is a text editor we tend to recommend in this class, A, because it works on Windows, Linux, and Mac, but also because it really is doing this on your text editor, never indent. This is an if with colon at the end, so we have to increase the indent, and now we're maintaining it, okay? So these 2 lines are part of that if, but now we have de-indented. So
yeah, that's what I was explaining. So these 2 print statements are part of this if block because of the indent. And as soon as you like go back or decrease the indentation, this is not even part of the if. So this is going to run regardless of this conditional right here.
This word or whatever, but where you do this de-indent affects the scope of how far this if statement lasts, right? It lasts up to, but not including, the line that's de-indented to the same level as the if. Okay, so this is a de-indent. Now we have a blank line, which doesn't matter. We maintain it. Now we have a for, which we'll learn about in the next chapter, which is a looping structure. For runs this 5 times. It has a colon, and also it expects an indented block. Now we have what's called a nested block, where we go in some more. So this is like 2 indents, right? So these are 1 indent, and these are 2 indents. And so this is a block within a block. And then we de-indent. So that means this print is not part of the if statement, but it's still part of the for statement. And then we de-indent again, and then that means this print is sort of on the same level as that for statement. So if you start thinking about this, you want to be able to start thinking that these blocks are the
So just know that indentation is really, really key here. You have to really know how this indentation works and how some of these blocks are created, because it's not like JavaScript where visually you understand in a function that this certain print belongs in this if because there's a curly bracket around it, right? So, this in this last one, which is what I think the answer is, this if of y equals 10 belongs to this block, and this print belongs to this block, which also belongs to this block. So I believe the fourth is the answer, right? Let's see. Given the following code, temp equals of string 5 degrees, Celsius is 0, Fahrenheit is equals float temp. Ooh, this is a little bit more challenging, huh?
So welcome back. Let's talk a little bit more about some more complex conditional statements that are built on this concept of if and if then else. The first thing we're going to look at is the multi-way branch. And so the idea is it's kind of like the if then else where you're going to pick one of 2, but now we can pick one of 3 or one of 4 or one of 5. And it introduces a new concept called the elif. The elif is another reserved word inside Python. And the way it works is, it's best to look at this here, where it checks the first one, and if it's a true, then it runs that, and then it's done. It doesn't check them all. It's not like it sees that there are 2 logical conditions. It actually checks them, the first one, and how you order these matters, as we'll see in a bit. And so if the first one is true, it runs. If the first one is false and the second one is true, it runs this one and it's done. And if neither of them are true, it falls through, and there's an else clause that is otherwise, and it runs that. So basically, it's either going to run one and then skip the other 2, or it is going to, skip 1, skip 2, and then run this one. But it only runs, in this case, one of them. But the important thing is it checks these questions in order. And it doesn't check the second question until it finds that it doesn't check the second question until it knows the first question is false. So if the first question...
Right. This is probably just conditional things. So right here, like the multi-way, right? Before in the recent exercises, we've only done if. So all those ifs were going to run regardless. And now this one is a multi-way. And so like he just said, I never got this professor's name. If this is false, right? So if x is not less than 2, we're not going to print small. So we're going to move to the next one, right? Elif, which means, in the JavaScript sense, this would have been else if, which I like a lot better. Elif x is less than 10, then we're going to print medium. And if that is also false, then we're going to go to else. But I believe if x was less than 2, we're going to print small. None of these would run, right? Because we're going to go print small and then go all the way down based off the diagram and then print all done, right? So same thing with the diagram. I hate elif as well. I don't really like it. This should have been else if.
It's true. You're done, and you're done with this. You're done with the whole block.
I agree. It could have been else if, but yeah, look at this diagram, right? So if we are going into the conditional. If this was a yes, we would print what's inside of that conditional block and then immediately move down and skip everything else. But if it was no, we'd go down. If it was no, we'd go down, right?
At that point. So only one of...
But this is not the case if all of these were just if. That's one thing to keep in mind, is if these were all ifs, all of them would run if the condition was true. If it's false, it's just going to get skipped and move on to the next one anyways.
These 3 is going to execute in that block. So here's sort of some examples of this. If we, for example, have x equals 0, it's going to come down here, x is less than 2, that's true. So it runs this code, and then it skips down to that. And so it's like this, runs that code, okay. On the other hand, if it's 5, then this is false, and it skips that, and it checks this is true. It runs this code, and then it's done, skips to the end. It goes like false, true, run, end. And then if x is like 20, for example, it runs, false, run the else clause, and you're done. So skip, else, run that code, and you're done. So in this case, we ran that, and we didn't run that, and we didn't run that. Again, one of them's going to run. They're checked in order. These questions are checked in order, not out of order. It doesn't look ahead. It just checks in the order that you wrote it. You're the one that wrote that order. And so there's a couple of variations on this multi-way. You can have no else. You can have no else, as in this case. And this just means that it might not run any of them. In this case, x is 5, so it's not less than 2, but then it runs this one. But if x was like 50...
The else is like your catch-all, right? You could look at it as your catch-all. But your catch-all. So if all of these are false, this is going to run in case everything that you set up here is false. So this is kind of just like print, in a case of like an error message or something, right? If every conditional that a user goes through is completely false and they didn't meet the conditions, we want to say, oh, sorry, you inputted something wrong. Something like that.
For example, if x was 50, then this would be false, then skip, and neither of these 2 would run. So if you don't have an else, you're not guaranteed that one of them is going to run, because else is like the catch-all. If the other ones are all false, then the else is the one that runs. Similarly, you can have many elifs, but this is where it's really important for you to make sure you know what order they're being taken in. So if this is true, it runs, it goes all the way to the bottom. If it's false, true, it runs this one, and it's done. If on the other hand, it looks at it as false, if it runs false, they're all false, then it runs the right? This one has an else, this one didn't have an else. They don't have to have them. The key is you can have more than one of these elifs. Okay? So I got a couple little things. I'll let you pause right now and look at, the question is, are there, looking at the 3 lines or 4 lines of code,
which will never print, regardless of the value for x. If x is less than 2, print below 2. If x is greater than or equals to 2, print 2 or more. Which will never print regardless of the value for x? Okay, now I'm confused. The else statement will never print? 3.10's been out. I'm on 3.10 because I'm an... Wait, can someone explain to me why the else statement wouldn't run? I don't know. I don't know why I'm so confused. Oh, I see. Gotcha. Okay, God, that makes sense.
X equals something. Are there lines of code that will never execute regardless of the value for X? And I'll let you pause and think about it, and then I'll explain it to you. Okay, hopefully you paused and thought about it as long as you like, so let me now explain it to you. So we come in here, and if X is less than or equal to 2, it's going to run this first thing, and if X is greater than or equal to 2, it's going to run this, and if neither of those are true, then it's going to run this. Well, the weird thing is...
If X isn't a number, it will throw an error. Yes, if X is not a number here, if it was the string of 2, this would not run.
All numbers are either less than 2
or just be false all the way through.
This to the point where it would never run this line of code. It is either going to run this one or run that one, but it's not going to ever run this one. Sounds kind of like a weird dysfunctional one that I constructed. This other one is a little different. If X is less than 2, we do this. If X is less than 20, we do that. If X is less than 10, we do that. And if none of those are true, we do that. Well, the problem here is between these two lines. The problem is if something's less than 10, like 6, for example, it's also less than 20. So even though there might be values for which this is true, those also are going to have this true. So for something like 6, it's going to run here, and it's not even going to look at this. That's the point. It doesn't even look at this. And so I could have made this more sensible if I had moved this little block of code up to there. So this is where the order in which you choose your questions, the way you put these LFs together matters because it doesn't look at all of them. It only looks as long as it can. As long as it sees falses, then it keeps on going to the next one. But as soon as it doesn't see a false, it doesn't continue. So the last conditional structure we'll talk about is the try and except structure. If you know any other languages like C++ or Java or JavaScript, you're like, well, that's kind of an advanced concept. But it turns out in Python, because of Python's propensity to throw trait in situations where you kind of would like to recover it, it turns out you kind of have to use it a little more and a little earlier in your programming skill. So the problem is, what if there is a line of code and you absolutely know it's going to make a traceback, it's going to blow up, but you don't want to blow up. I mean, I don't want to have code blow up. If you're using my autograder and you see a traceback in my autograder, that's kind of like I consider that a failure. I could put an error like, hey, you entered blank data or you didn't enter a number, but a traceback, that just seems like I'm too lazy as a programmer. So we as programmers are supposed to anticipate parts of our code that are going to blow up potentially based on perhaps the user's input and then do something about it. And that's what the try and accept are for. If you take this little dangerous piece of code that might break and might blow up and you surround it with a try and says this might blow up, and if it fails, run this code down here. So that's the try, and if you get an exception, the accept is kind of like if you get an exception. And the problem is if you are running code, here's a little bit of code, put hello Bob in and we convert it to an integer, and we know from past experience that this blows up, right? You can't take hello Bob and convert it to an integer, it's just going to blow up. The problem is oh, you up on line 2, that's great, and I'm not very happy with hello Bob, and your program stops. These other lines, they don't exist, right? It doesn't go any further. Because I'm really confused and I don't know what to do next. So Python is just going to be conservative and stop. And stops, and your program stops. No matter how much error checking you put down here, it doesn't matter because it's gone. It's all gone. And like I said, we take this kind of personally because the code that you write is like you being put into the computer, giving it instructions. And if the code blows up, well, that sort of wipes you out. You're not in the game anymore. You're not able to do anything. So we want to be able to, especially in these situations where we can anticipate that an error that might happen in the normal course program's execution might be something that you want to compensate for. And that's what the try and accept does. So here's a bit of code for the try and accept. And we just have 2 little bits of straight line code. And so we put a string in here that's hello Bob, and then we're going to convert it to an integer. This is the dangerous code. This code in this case with hello Bob is going to do a traceback. And so we say try, and then we indent the dangerous code, and then we add this little accept bit. If it works, the accept is ignored. If this blows up, it runs the accept. So in this code, it's going to come in, it's going to try this. This is going to blow up. But instead of giving a traceback, it's going to say, oh, I've got an available accept. I'm going to run this accept code, and then I'm going to continue on. And so that prints out first -1. So because we set this variable Eister to -1, like a little flag telling us that something went wrong. And then we keep...
Yeah, so I guess this is very relatable to the try catch in JavaScript, where we're going to try a block of code. In case it blows up, we don't want the program to stop, pretty much. And then we're going to accept, if it does blow up, we're going to run this block of code.
Keep on going, and now we have put in 1, 2, 3, the digits 1, 23, the digits 1, 2, 3, and now it's going to work, but we still have it in a try block, and then this one works, it does not blow up, and then it ignores the accept block. So the accept block is only triggered when something goes wrong in the code. It is ignored if something doesn't go wrong. So it's like you bought an insurance policy on this line of code, and when things go wrong, the accept block springs into action and does whatever it is that you want it to do in the case of an error. Okay, so that's a pretty useful thing. You got to be a little bit careful that you don't overuse it, because if you put more than one line inside the try part, and one of the lines blows up, it doesn't come back to the try block. And so in this one here, we have kind of a simple, silly one, where we set the string, we're worried about some stuff, the print statement's never going to blow up, so it's a bad idea to put it in try except anyways. Then we do this conversion, and that's the dangerous part. And in this one, so then it's going to go to the accept block and then run the accept block and then continue. What it doesn't do is somehow go back and finish this. So these lines,
yeah.
So if you look at it like this works. The try starts, hello, this blows up, it goes to the accept, it runs the accept, and it continues on. Never runs that code. So it's not like you took out an insurance on the whole block. Any of those lines can blow up in the block, but whichever line blows up, that is the last line that's executing in that block. Okay, so my block, and we're going to set -1 if that's a failure. It's for the code to kind of blow up.
Okay, so she's still going over tries. So we're going to do this. This one I'm kind of like, my math isn't great. Which line should be surrounded by the try block? I'd imagine this. So line 4 should be surrounded by the try. Oh, you're saying 3? Oh, because we're doing an operation here. Temp is string. Right. Yeah, that's true. Okay. I would have said 3 and 4, but oh, look, you guys are wrong. It's 3 and 4. We were both right and wrong at the same time. We'll take it. We'll both take that L, okay? All of you were so confident. It was just 3. I even said 4, okay?
Hello and welcome to Chapter 4, Functions. This is
We're moving really fast through some of the basics of Python. We're moving really fast.
4th of our basic patterns. We'll get to iterations next. Functions is the store and reuse. One of the things in programming is that we never like to repeat ourselves. We don't like to, if we have 4 or 5 lines of code and we're going to do the same thing later, we don't like to put the same 4 lines of code in, even if it has to do with reliability. If you find something wrong with those 4 lines of code and you've got them 12 places in your program, then you got to find all 12 places and fix them. So collect those to one place and then call them and reuse them. And that's the idea of store and reuse. So this is how functions work inside of Python. The first thing we notice is there is a new keyword def that stands for define function. And the def is like an if statement, or we'll see 4s and y.
I kind of just answered your question here, right?
And an indented block, and then the indented block de-indents, and that's the end of the function. And so these 2 statements make up this function. The key thing that you have to understand and get used to is this this def part is actually not running any code whatsoever. It's actually remembering the code. And that's what I call the store phase. The def creates a bit of code and records it like a macro, although it's much more complex than a macro. And it names it whatever you chose. You gave it a name. We named this one thing. And so it, as a side effect of Python reading or parsing these 3 lines, it doesn't do anything, but it remembers. These 2 lines are what you would like to run when you invoke thing. So this is the definition of a function, and this is the invoking of the function. But so this doesn't do anything. So there's no output here from that stuff right there. But then what happens is you invoke it. And this thing looks like it's part of Python, but you in effect have extended Python with your def statement. And so when it sees thing, it goes up and runs your code. And so out comes hello fun. And then it comes back and goes to the next line, does print. So print comes out. And then it goes back like, oh, this is the reuse part. Well, we get to reuse it. We define it once and we use it twice. And it runs this code again. And it goes to the next line and it's all done. So this little bit came out twice. So this is really simple so that I can fit it on a page. But you get the idea that I don't want to repeat. This might be, 15 to 100 lines of code. And I don't want to type those over and over again. So I say, hey, store these in a name that I choose and then again. Okay? So that's the basic idea. We actually have already been using functions from the beginning. The print is a function, right? Print is a function. Every time we see print, P-R-I-N-T, parenthesis, and then we have some stuff in here, we're calling the print function. This is the syntax with 2 little parentheses. It's the syntax for functions. And so input's a function, type is a function, float's a function, int's a function. All these things are built-in functions that come with Python at the moment that we started. I mean, it just came along. And then there's other functions that we define and use, and that's what the def is for. And in effect, we can create new reserved words of our own making that extend the Python language after we define the function. So it's just this bit of reusable code that takes some arguments. We haven't seen any with arguments. There's a little parenthesis, and we'll see how that works in a bit. We define using the def keyword, and then we invoke it. There's the defining phase, which actually doesn't run the code, it just remembers the code, and then there's the invoking phase. You define it once and then invoke it 1 or more times. Calling the function or invoking the function, we think of those 2 things as the same thing. Call, invoke are just the terms we use. Most people just say call the function, but invoking is perhaps more to say to think about it. So here's an example of a function. It is built into Python. It's called the max function, and we can pass some parameters into the max function. So we pass the hello world string. Now, like much of Python, max knows what kind of thing is being passed into it, and it knows that it's looking for the largest character, the graphically largest character, and in this case, it scans this little, that's inside the max code, it scans through and finds the largest character. So apparently, lowercase letters are higher than uppercase letters because in English, we get back. So this is what's called the return value. So this is an assignment statement. Let me clear this and start over. So this is an assignment statement, so it has to evaluate this right-hand side, and a function call is nothing more than like x plus 1. It's something to evaluate. It runs the function code, passes in this argument, and then this residual value, this is called return value, we'll look at this in more detail, becomes the result of this little bit in the expression, and there's nothing else. And so we can think of this as invoking or calling this function as this right-hand side is being evaluated. Store, put all this code in for you.
Okay, pretty sure we understand that part. What is the purpose of the def keyword in Python? Chat? Any guesses? Any guesses? Slang that means the following code is really cool. I think that's the one. It's 2. Oh, am I wrong? Is it this? Wait, yeah. Okay, well, I had it already. It might be. We might be able to do it. Build your own functions. Okay, what will the following Python program print out? So we have a function Fred, which prints zap, function Jane, which prints ABC. Pretty sure we can skip this because, yeah, work smart, not hard, boys. Exactly. So we have a Jane, which prints ABC, a Fred, which prints ABC. So ABC, zap, ABC. So we agree, ABC, zap, ABC, right? It's because we're defining a function called Fred. These are where our parameters or our arguments would go. And then a colon. Indentation means this belongs to the function of Fred. So every time Fred is called, which we're doing right here, we'll print zap. So we can reuse this block every single time. Same thing for Jane, except we're printing ABC. So it is ABC, zap, ABC. Very good. That's an easy one. Loops and iterations. This one's a big one, right? This one's a big one with looping. So for loops, while loops, things like that. I think we should watch this video.
Hello and welcome to Chapter 5, Loops and Iteration. Now we're going to work on our 4th basic pattern of sequential, conditional, store and reuse, and loops and iteration. And this is the one where we teach the computer how to do things a lot. We can tell it to do something a million times. And so that's where we get the doggedness of computers, or the fact that they're so good at doing work for us because we can set them off to a task and they'll do it until it's done. So here's a very simple loop, coffee over here. The keyword that we're going to start using is the while loop. We're also going to use the for later on. In the while loop, the function's very much like an if statement. The while starts it, and then this is just like an if statement. It's a question that leads.
So pretty much like these diagrams help so much, right? So n equals 5. This is a while loop. So while n is greater than 0, so that's the condition that we're asking. While it is greater than 0, we want to print the value of n, which right now it's 5. We'll go down and then we'll reassign n to a new value, which is going to be its current value minus 1. So this will be 4, and then we'll go back up. This new value will be n equals 4, still greater than 0, and then we'll keep going down until if n is greater than 0, which eventually gets to 0, which it will be no, and then we go down to blast off, right? It's a pretty simple, like the flowchart makes it so easy to understand. So I would recommend that you draw these out yourself and try to understand these too. If you want to create your own cheat sheet for while loops or for loops to understand the flow of things, I think that'd be very, very useful.
Leads to a true or a false answer. And then there's a colon and then there's an indented block, and then we use the de-indent to determine how long the loop is. And so this print is de-indented, so that indicates the end of the loop. And so at some level, what's going to happen here is it's just going to run, and if this is true, it's going to run this code, and if it's false, it's going to skip the code. In that way, it functions like an if. The place that it doesn't function like an if is after it's run the code once, it goes up and then asks the question again. And so you can think of it going back up kind of to the top of the while loop and then re-asking the question, like, okay, is this going to run again? And then it's going to do that some number of times, and then it's going to finish. And so that's the loop, that's the iteration. And we're going to make a variable, we're going to construct very carefully a variable that we call the iteration variable, and that's n. And it's a variable that's going to change, and it's our way of running the loop, but not running the loop forever. So let's just run this. We come in, and it's 5. Is n greater than 0? Yes, it is. So we're going to run this code. So we're going to run this code. We're going to print out 5. Then we're going to subtract 1, and then we're going to go back up, and ask the question: is n greater than 0? And the answer is, since it's 4, the answer is yes. So then it runs again. Then it prints out 4, subtracts again, checks, prints 3, subtracts again, prints 2, subtracts again, prints 1, subtracts again. Now n is 0, and so it comes back up. Is this question has now become false? So it's going to take the exit. So it's going to come down and run this line right here. Then it prints blast off, and we can kind of print out the residual value then just to sort of each time through the loop and n is still greater than 0. So you can pretty much see, because we're not changing n.
Oh, this is a big one, infinite loop.
It's going to be true forever. And so this is an infinite loop, and it's just going to run until your computer runs out of battery, or you hit the button. This is the kind of thing where you often see your computer spinning like a spinning beach ball, or some other indication that your computer's super busy. It's in some kind of a loop, really tight, and it's running something, and it's using up all of the processing resources of your computer. That's an infinite loop. And so the problem is we did nothing.
Why? Because we don't change n at all, right? We're just printing two things. So this will keep running forever because 5 will always be greater than 0.
With the iteration variable. Now here's a different loop. So this one demonstrates a different idea. So in this case, we start out with n is 0, and it comes in here, and is n greater than 0? Question mark, and the answer is false. So it skips it. It doesn't run these lines of code at all. And so this loop doesn't run at all, because it comes in, asks the question, it says no, and then it skips right around it. So never run. And so this actually is, sometimes you write a while loop on purpose like this, not quite as simple as this one, but the idea is this emphasizes that these loops are what we call zero trip. They are not even guaranteed to run once. They're going to run maybe 0 times. And in this respect, it functions exactly like an if statement, right? Meaning the first time through the loop, if it's not true, it's just going to skip right by it. So there's a couple of ways of getting out of loops. In this case, I'm constructing an infinite loop, because remember, the definition of an infinite loop is if this is going to stay true. Well, true is a constant true. So this is going to run forever. And what's going to do is it's going to prompt with a little arrow, and then let us type and read whatever we type into the variable line. And then if the line is done, we're going to break. Now break is an executable statement, and if you hit the break, it exits the innermost loop out to the place beyond the end of the loop. So when this runs, when we say hello there, line is not done, so it prints it. So it prints out hello there, and then goes up. And then we type in again, we type finished, and so it's not done, so it prints it. So now comes that print statement. And then we type in done, and now this becomes true. And it comes out and runs the code beyond the end of the loop. The key is it doesn't go back. It's like once you've done a break, that loop is done. So you look at basically, the block that is the loop. So here's kind of the loop block, and then the break goes to the line after the end of the loop block. And you can think of this as sort of like just a hyperspace jump. There is nothing really. This could be literally hundreds of lines with if statements, and you could be running and doing all kinds of stuff and running and doing all these things. And these things could run all kinds of ways, right? The point is as soon as you hit a break statement, however much stuff is down here, however much stuff is up here, it exits to whatever the next line is beyond the end of the loop. Continue is another loop control statement, but it works differently than break. So break says get out of this loop. Continue effectively says stop this iteration. We're done with this iteration. And so continue says go up back to the top of the loop. Oops. Go up back to the top of the loop. And so here we read a line. If the first character is a pound sign, we're going to skip it. And this is a way for us to make like little comments in our typing. And then if the line is done, we get out, and otherwise we print it. And so that's why there is no printout here, because it comes in, runs, it comes in, this is true, and it goes back up, but it comes back and prints out the next one and does another thing. And so the loop continues, whereas the break ends the loop. And so again, the same kind of notion that you're sort of doing all kinds of complexity. Wherever you're at in this loop, you hit continue, and it doesn't go any further. It goes back up and it runs the question mark. It asks the question mark. And asks the question, and it might exit the loop in that particular case. But this one here is a true, this is an infinite loop that I've constructed. This is not an infinite loop, because at some point the break gets us out of the loop. And so it's an infinite loop with break to escape it. And that's another common way to construct a loop. So these loops that we've been drawing so far, the ones that use while as their key, and that's because they kind of go for a while, till a break hits or until some value becomes true. As long as that remains true. So all the ones we've done so far are easy to look at and know that they look pretty good and they're probably going to finish. But there are sometimes, if they're long and complex and their exit or termination conditions are a little more complex, it's not clear that they're really going to terminate. And so we can use while loops for a lot of things, but for most of our looping, we're going to use what are called definite loops, and that's what we're going to talk about next.
Cool. So what will the following code print out? N equals 0 while true. If n is equals to 3, break, print n equals... It's going to print 0 first, because this is going to be, once n is equals to 3, then we're going to break out of this loop. So it's going to print 0, 1, 2, and then once n is 3, then we're going to break. We're never going to reach this, so it'll be 0, 1, 2. Everyone agree? Very nice. So for I in, okay, so this is for I in 215, print I. How many lines... Chat, what do you think before we go into this? How many lines do you think are going to print out of this for loop? I already know the answer, but...
So definite loops use the for keyword. And the idea of a definite loop is it's going to loop through some set of things. It might be a set of lines in a file. It might be a set of characters in a string. It might be a set of strings in a list of strings. But whatever it is, it's sort of going to run a finite number of times, depending on the thing that it's looping through. And we like this. And it's an easier way to construct it, and we actually don't have to deal with the iteration variable. The for loop includes a mechanism to construct the iteration variable for us. So it's definite loops iterate through the members of a set. So here's a very simple for loop. And so you see the for keyword, and in is also a keyword. And the iteration variable is something we put right here. This I is declared. This I is like an assignment statement. And I is going to take on successive values. So I is going to be 5 the first time through the loop, then I is going to be 4 the second time through the loop, third, 2, 1. So I is going to be assigned 5 different times to 5 different values, and then the loop is going to run. It's going to run once with 5, once with 4, once with 3, once with 2, and once with 1. And so this block of code we have contracted, say, execute it 5 times with these values of a thing changing through each iteration of the loop. Okay? That's why this prints out 5, 4, 3, 2, 1, and then when it's done, it finishes it. So this is a much more direct syntax for looping 5 times and setting an iteration variable. You kind of all combine it into this one thing, right? All into one thing. So it's quite nice. So you don't have to be going through a list of numbers. There's all kinds of things that we can iterate through with for. And by the way, while I'm sitting here, I named my variable friends, because that's a list of strings, and friend, which is the iteration variable. I'm using singular and plural because it helps you read it. Python doesn't understand singular and plural. So just because you say friends doesn't mean Python knows it's a list. Python does know it's a list, but it doesn't know by the name of the variable I've chosen. That's your basic mnemonic variable warning. These are cool variable names, but I don't want you to get confused by them. So you can loop through a variable. So we're going to take this list of 3 strings and stick it in friends. And so friend is going to iterate through that. So the first time through, friend is going to be Joseph. Second time through, Glenn. Third time through, it's going to be Sally. And so that just says run this code, the indented code, 3 times. Each time the variable friend takes on a successive version of a successive value that's in the friends array. So it says happy birthday Joseph, Glenn, Sally, and then we come out of the loop and we print done. So if we try to draw a picture of what this is really doing, the for loop is actually doing a whole bunch of stuff that we would have to do with.
Yeah. Okay. So this is like, I mean, basic for loop. So for I, which is like, I guess you could read an item inside of this array, which is 2, 1, and 5. There's only 3 items in here. So we're going to print every item that we loop into. So every item in this array can be seen as I, or an item.
Maybe separate statements in the while loop. First, it decides how many times to run the loop. So it's answering the done question, which way do we go? And it is also then moving I ahead. It's managing the iteration variable. If you go back to the initializing it loop, we had n equals 0, while n greater than 0, n equals n minus 1. So we had like 3 lines to control the loop, to manage the iteration variable. The for loop, we don't have to do that. And so that's all taken care of. And so that basically says, you know, the for loop, by you using a for loop, are we done? No, we have 5 things to work. Well, set the first one, run it. We're not done because we got one more, set it to the second one, third one, fourth one, fifth one, and now we're done. And that is all handled in a single line of code, and that includes the iteration variable and the set of things through which we are going to iterate through. I really like the word in. It is mathematically, I mean, it reminds me of set theory, where you say this is a member of this set, or the for each. Now, math isn't important here, but if you do know math, the vertical bar means such that, right, is a member of this set, and that kind of stuff, member of the set. I'll erase the math stuff so we don't over math. But it's like for each of the values in the set 5, 4, 3, 2, 1, run this loop, setting the iteration variable I to the members of that set. So in reminds me, for those of us who are math oriented, in reminds me of a really nice concept in mathematics. Okay. Now you could think of this as sort of this looping structure where the for loop, and this is pretty much how it actually runs inside the computer, right? Where it initializes, it runs this thing 5 times, and then executes. That's one way to think about it. But you could also think about it in a somewhat more abstract way, and think of it as all we're really doing is we have a contract with Python that says we're supposed to run this code 5 times, and I is supposed to be 5, 4, 3, 2, and 1. So you can imagine this might be what's going on. The for loop sets I to 5, runs our code. The for loop sets I to 4, runs our code. The for loop sets, all we know is our code was ran 5 times, and by contract, each successive time, we're getting a different value for I, and the value for I is taken from this set. And so
yeah, okay, so you can look at this as an iteration value or item. It helps for me to look at this as an item. We already said 3 times because there are 3 items. So for item in array of 2, 1, and 5, you are going to print I. So iteration value at first is going to be 2. It's going to go back in. It'll print 1, and it'll go back in and print 5. There's no more items in there, so we're effectively done in this for loop, right? So there's going to be 3. Perfect. Okay, I think this is a good place to stop. I don't want this to be too long. We're not going to spend 300 hours on this. This is good. This is very good. I may do more of this, like not on Fridays, even though Freecodecamp Fridays is a pretty cool thing.